let me describe for you another cellulose version, which again we use for its structural properties. Cotton wool. Right, if I take out a nice chunk of that, we're all used to cotton wool, jolly good for cradling things, and it's all made of fibres. That's all extremely familiar to us, cellulose fibres. And if we twist this, I'm a rather inefficient at this. If you do that efficiently by machine, then that is the thread that you get. You get a cotton thread. And that's a useful thing for sewing up things and holding things and so on. Very important structure. And then we can think, okay, but, well, that's not much good, is it? It's not very strong. That's a rotten piece of thread. But what I want to try and impress on you is the fact that it's actually a bit stronger than it looks. That's a rotten little demonstration. So let's have a competition. We're going to have a molecular competition. Very simple. Thank you very much. Here's the arena for this competition. Now, can I have a couple of volunteers? Thank you very much. I need a team, you see. Thank you. Please come down. What's your name?
Simon.
Simon. Hello, Simon. And your name?
Victoria.
Victoria. Okay, jolly good. Now, I want one of you to be Cotton, and so you can be there. Okay. And you can come this side, Victoria. Okay. Now, let me just explain what this extremely sophisticated demonstration is. Okay. What we've got here is a steel wire. Steel. It's made of steel. And on this side, we've got a wire which is made of cotton. Right, now, which do you think is stronger, cotton or steel? How do we test this? This is a Royal Institution tensimeter. That's a fancy name for it. Right, okay. Now, what we're going to do is successively load these wires with weights, which are hiding behind here. So will you put on a weight, please? Thank you very much. That's a ½ kilogram weight. Okay, so that's 500 gram weight on each one. Very gentle, so we don't perturb anything. And notice that the tensimeter is reading 500 grams. Right, okay, and both of them are holding. Let's have another one. Very good. Very good. We're now up to 1 kilogram. Tensimeter's reading that on each side. Exciting, isn't it? Right, okay, let's have another one. And, oh, it's gone. But his is holding. That's the steel one. So the steel one has gone first. All right? I tell you what we're going to do, Victoria. We're going to borrow one of your weights and give it to Simon. Would you like to try that on yours and just see if it'll take one extra? And it's still holding. Right. Thank you very much indeed for coming to help us with that. That's fine. So there must be something special happening in this cotton thread to make it so strong. And if we're going to find the reason for that, we must go, thank you very much, we're finished with that, we must go to the molecular level. If we want to understand phenomena, we must go to the molecular level. Chemistry. Right. Now I remember that I said that this thread was made up of glucose units all stuck together. Here is the glucose molecule. Now, let me just tell you about the structure of this molecule. First of all, this red ball is an oxygen atom. And the pale blue ball is a hydrogen atom. And if you look at this molecule, you'll see that that grouping, this hydrogen-oxygen grouping, is represented several times in this molecule. And it is actually the association of these hydroxyl groups, HO groups together in the thread, which make that thread strong. These are sticky groups, and we're going to come back to molecular stickiness. Now let me just take you from the individual unit to a model of cellulose. Here we are. A string of glucose molecules, and the sticky groups that we've just seen represented by these white dots. Okay? So now let's go up from this model, this molecular model of cellulose, to a piece of thread. Okay? And if we stretch that piece of thread down the length of that model, then what we are doing is representing the thread at the molecular level. And it is the stickiness between these chains of the hydrogen-oxygen grouping that we've just seen which gives cellulose its strength. In this case, its tensile strength. It's a molecular association phenomenon.